In section 7.5, we're looking at proportions, and it says we have a proportion equal to 0.27. Calculate the standard error of the proportion for the following sample sizes. And you can see in the example, you can always get the formula that you need in the sample. So this is the formula we'll be using, where P is the proportion and then N is the sample size. So to calculate the standard error of the proportion, we would plug in the numbers for that particular formula. So the square root of P, we know P is 0.27, and 1 minus P would be 0.73 over the sample size, N. So for A, N would be 45. So if you do that and plug that in, you will get 0.0662. You're rounding to the nearest to the fourth decimal place. For that would be for A, and then for B you would do the same thing, but except this being 45, we would plug in 90 and get the standard error, and you would get 0.0468. And then it's still 0.27 times 0.73. And then for the last one, you would put 135 down here and calculate that, and that's how you get 0.0382. So you're just using the formula here. Now moving on to the next question. Question number 2, it says we know the sample is 125 and the proportion is 0.55, and we have our tables here. Determine the probability of observing 67 or fewer successes. First, we will have to calculate the standard error of the proportion. So we would do that first. So we know that it's 0.55 for the proportion, and then 1 minus 0.55 would be 0.45 divided by N, and we know that N is 125. Okay, and when you plug all of that in, all of that into your formula, let's see what I got for that. Column 2. It looks like I got 0.0445. 0.0445 is my standard error for the proportion. Now, to find our z-score, we have to take the probability of observing 67 or fewer. So we have to get a proportion out of that. So we have to do 67 out of 125. So if you do 67 out of 125 and you round that to the third decimal place, you get 0.536. So that probability minus your probability, your proportion at the top, which is 0.55, over your standard error, which is 0.0445. So if you do that, you will get, I believe we get negative 0.31. So we have to go to our table and we have to look up negative 0.31. So if you go to negative 0.31, you get 0.3783. So there is our probability for 67 or fewer. Now, we still use the same standard error of the proportion, which was 0.0445 to work all of these. And we know P is always going to be 0.55. But for B, the probability of observing 71 or fewer, well, we have to do 71 out of 125. So if you do 71 divided by 125, see what I got there. I believe I got 0.568. So when we're calculating our z value for our proportion, 0.568 minus 0.55 divided by your standard error. Once you do all of that, you end up with we're going to round because when we look it up, it's only going to have 2 decimal places, so 0.40. So that's what we're looking for in the table. So if we go to 0.40, 0.6554 would be the probability of 71 or fewer. And then 63 or more, well, 63 or more, 63 out of 125, and that would be 0.504. The key here is rounding where they want you to round. For the proportion, you round to 3 decimal places. So you get 0.504 for the z-score, 0.504 minus 0.55 divided by the standard error. The standard error, we're rounding to 4 decimal places. It's the same one we've been using, and you get negative 1.03. So if you look that up in your table, if you look up negative 1.03 in your table, you're going to get 0.1515. But we want greater than side. This is the less than side. To figure out the greater than side, we do 1 minus 0.1515, and you get 0.8485, which is what we have over here. Okay, so let's keep moving on and look at the next problem. This is basically the same thing. You have to we'll go through the whole process for 38 and the whole process for 45. Do 38 out of 100, which would be 0.38, and do that would be P for the first one, and 45 out of 100 would be P for the second one. And you have to figure out the z-scores and the probabilities for both of those. Go through all the steps, and you will get the probability of this one and the probability of this one. You'll get those numbers and you subtract them. Okay, so it's the same process we've done before, except it's a proportion problem, but it's the same process when you're using the table. I wanted to do one where we have a sample and we have a population. Now, this is something extra here. So if you have the population proportion and the population size and the sample size, what you have to do is you have to do this population correction factor here, okay? And so with this, we have an extra step when we're doing the standard error, okay? So let's go ahead and do that. First of all, let's just figure out the standard error because that's going to take some time. We know that P is 0.40. We know that little n, the sample, is 175, and we know that big N is 400. So what you have to do is the population correction factor. This is problem 4. So the standard error would be the square root, just like we done before. The first step is the same, 0.40 times 0.60, they have to add up to 1 over 175. Then you have a times by big N minus little n, so 400 minus 175 over big N minus 1, so 400 minus 1. So if you get all those numbers, do this one and the second one, and work it all the way out, or put it into your calculator, you end up getting 0.0278. 0.0278 as a standard error of the proportion. So it's very important that you work all of this and try not to round until the end and round to 4 decimal places. So if you had a TI-84, it would be a lot easier to do this step. Once we get our standard error of the proportion, we can start working on our z-score. Okay, so always get the standard error of the proportion first, and then you can start working on your z-score. Now we want between 65 and 72. So what I'm going to do is I'm going to put our standard error of proportion up here, which is 0.0278. So I have all my information up there. And now I'm going to start getting the z-score for the 65 and the 72. But I have to make these proportions. So you have to do 65. You have to do 65 out of, I believe it was 175. 65 out of 175, and you get 0.371. So 0.371. We'll do the z over here. And then if you do 72 divided by 175, you get 0.411. So we have to subtract that from our proportion, which was 0.40. And then you have to divide those by the standard error, which is 0.0278. And then you get a z-score for the first one of negative 1.04 for z. And over here you get a z-score of 0.40. So if you look those up on your table, you get 0.1492 on this one. And over here you get 0.6554. Now we want it to be less than this one. We want it to be between these two. So what you have to do is you have to take the big one, the area of the whole, and subtract out the area of the smaller one, like we've been doing all along. So you do 0.6554 minus 0.1492, and you get 0.5062. Remember the standard error, remember the curve. We want in between, okay? Well, this 0.6554 represents the area from here all the way back, okay? But we don't want all of that. We want the area in between these two. So we have to take the area of the whole and subtract out this 0.1492. 1.1492, that's the area of all this over here. So what we can do is take the area from here on back and subtract out this little piece right here, and that would tell us the area or the probability in between. Okay, and that is pretty much it. If you keep scrolling, you will see some very similar. If you need access to the table, one thing you can do if it doesn't give you access in the homework, you can go to Canvas and go to our course, and you can click on modules, and you can go to the proctored exam module, and you can click on the formula sheet. And if you click on the formula sheet and scroll down in the formula sheet, you will see the table. So if you can't find the table, or it's not giving you the table on some of these problems, you can always have it pulled up. It's taking some time, so I may run out of time. But if you pull up the proctored exam formula sheet and scroll down, you will have access to the table, the positive table and the negative table. So you can print those tables off too. That may make it quicker for when you work on the homework.